polynomial is given by px. You know what f of x is. That's a function. So p of x is just a different, it's just a different letter, okay? So it's also a function. It's anything that looks like a1, that's a coefficient x to the power of like n plus, could be like b2, a1, a2, sorry, and x to the power of n minus 1, etc., etc. So I said that an example of a polynomial is like 3x to the power of 2, like 2x plus 1. So that's an example of polynomial. I think everyone's good with that. So another example of polynomial is like if you have like root of 2 and then x to the power of 3, that's a cubic, plus like 4x squared, etc., like plus 1, for example. That's also a polynomial. So the first one is a polynomial of degree 2, and which we call that quadratic. You can all see my screen, is that correct? Yeah. Just feel free to interrupt anytime if you have any problem, okay? If you don't understand anything, okay? From next time, we're going to try maybe a different software. It's called Zoom, okay? I'll give you the instruction for it, and I think this is a lot better than Blizz. All right, so this one here, you can't really see each other, but in this case, we can see everyone. Everyone can see everybody, okay? So, but if you don't want to show your face, that's okay. You can hide yourself. It's up to you. Anyway, so I'll just keep going, keep talking, okay? So polynomial. So if you have something like, let's say 3x to the power of half plus like 2x to the power of, I don't know, like 2. So this is not a polynomial. The reason is you cannot have x to the power of non-integer. So you can only have, so for a polynomial, so this n here, whatever this exponent is, has to be only positive integer. So that means like 1, 2, and 0 as well. 0 is fine. Okay, 1, 2, 0, 1, 2, 3, 4, etc., etc. Even negative is not okay. So what about this one? So if you have a function that is 2x to the power of, what about this one? Like 2 over x squared plus 3 over x plus like x to the power of 3. Is that a polynomial or not? I want you to think about that. Yes or no? Maybe we can put it to a vote. Maybe on a chat box you can say, you can write yes or no. Okay? Maybe you can just, instead of clicking all participants, you can say, if you want to just share your answer with me only, you can just click on, so on the left panel, you see the Blizz panel, you see the all participants, or you can actually see this, right? So you can just click on me only and send your answer. Then I'll be able to see the answer, see your answer, but other people are not going to be able to see your answer. Okay? If you don't mind sharing your answer with other people, then you can share it to all people. Okay? So I want you to think about that. And just write your answer. I'll give you 30 seconds. I haven't gotten the answer yet. All right. So someone said no. Someone said no. You guys all have to write your answer, okay? Someone also said no. Come on. If you don't know, just write random answer, okay? Yeah. Okay. All right. Got another answer. I'm just waiting for one more One more answer, one more. Okay. Right, the answer is no. All of you got it right. All of you got it right. Yeah. Okay, so the reason is, this one here is the same thing as 2x minus 2 plus, you know, when you have 1 over x to the power of n, so it's very important to know that this is same as x to the power of negative n. Okay, so let me just talk a little bit about this one here. If you have 2 to the power of 3, this is 2 times 2 times 2, right, which is 8. If you have 2 to the power of 4, then you have 16. If you have 2 to the power of 2, then it's 2 times 2, which is 4. And if you have 2 to the power of 1, then you get 2. And 2 to the power of 0, I want you to figure out the answer for this one. I'll give you, and write your answer on the chat box again. 10 seconds. Yep, I got 2 answers. Waiting for 2 more answers. Okay. 1 more answer. What's 2 to the power of 0? If you don't know, you can use calculator, okay? 1 more answer. Okay, good. So everyone got 1. Okay, good. Everyone got 1. By the way, maybe I'm going to try sharing my, maybe I could share my face as well on the, maybe for those of you who have never seen me. Just give me a minute. Can you see me? No? I tried, yeah, don't worry about it. I'm going to just close it out. All right. Now let's go for 2 to the power of minus 1. Okay, what's that? You know, if you can see this one, so 16 divided by what is 8? Divided by 2 is 8, true? 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is also 1. Is 1, right? So 2 divided by 2. So what's 2 to the power of minus 1? That's, of course, 1 divided by 2. So that's 1 on 2, you know? What about 2 to the power of minus 2? Then that's equal to this one divided by 2. But, you know, half divided by 2 is half times by 1 on 2. So this is a 1 on 4, etc., etc. So that's why you get this rule. Okay, so what's the 2 to the power of, this is, you know, quarter is 2 squared. So 2 to the power of negative 2 just becomes 2 squared, but on the denominator. Okay. Chris, you said negative 2? For which one? Yeah, 2 to the power of minus 1 is actually not negative 2. 2 to the power of negative 1 is actually 1 on 2, as you can see here. Yeah. So a lot of people think that 2 to the power of minus 1 is actually minus 2, but it's not, okay? Yeah, that's a common misconception. So anyway, as you can see, this is not a polynomial because this one is this, and this one is basically 3x minus 1 plus x to the power of 3. And definition of polynomial is the exponent has to be a positive integer or 0. Okay, so that's the definition of polynomial. Now, we are going to so last time, just a little bit of revision from last time. If you have a polynomial which is fully factorized, so something like this. Well, I taught you how to plot any polynomial, true? So I think Chris was here, and Philip was here, and Yechan was here last Friday when we talked about polynomials. So Because it's first time for some other people, I'm going to go through this again, and it'll be good revision for the people as well. All right. By the way, our lesson today will go from 7 until 9 p.m. Okay. So in order to plot a polynomial, it's very easy. You just have to know a few things. First, you need to know the roots. Right? In this case, it's a 1, 2, 3. So if you have x minus, let's say, alpha, and that means alpha, so this is x-axis, alpha is a root. So if it's the power 1, then the graph will pass through sort of in a linear manner, okay? Now, if you have x minus alpha square, then it will just bounce off. The curve will bounce off this alpha, either from above or from below, like that. True? Now, if you have x minus alpha to the power of 3, then it will still go through the alpha, but it will pass through, sort of it'll become flat and then go up like this, either like that or like this. So that's what we learned on Friday. That's just a revision for some of you. And number 2, if it's a cubic, if it's a quadratic, so if the order is 2, 3, 4, 5. If the order is 2, of course, it's quadratic, so it's going to look like this. Or it's going to look like that. So it depends on whether A is positive or A is negative. Yeah. So what's A? So A is the coefficient, the coefficient of the leading term of the leading term. So for example, if you have y equals to like 4, hold on, why is it not? Yeah, y equals to 4x squared plus 2x minus 3, this guy here, that's the coefficient of the highest order term, right? So I just call that leading term. So that's 4, which is positive. So in this case, this quadratic will look like that instead of this one. So if that was a negative 4, it will look like this one. Okay? For cubic, it will go like this. So it tends to positive infinity. As you go to the right, it will tend to negative infinity on the other tail, okay? And if A is negative, then it'll go the other way, like this. So that's the general shape. For quadratic, it will look like this. They both face the same direction, positive infinity and positive infinity. If A is negative, then it will tend to negative. Both tail will tend to negative infinity, and so on and so forth. If you have a power of 5, you guys can actually try that. What would it look like? So for example, for order 2, you can maximum have 2 roots. We call them roots. So the x-intercepts are sometimes called roots. So this root is not the same as this root. Okay, so this when we say roots in the context of polynomials, they are x-intercepts. Okay, so these are x-intercepts. So for quadratic, you can maximum have 2 roots. This is x-axis. You can maximum have 3 roots. 1, 2, 3. You can have 1, 2, 3. This is 1, 2, 3, 4. 1, 2, 3, 4. Okay? Like that. So I want you to maybe predict the Pentek function. Pentek polynomial. I'll give you. So one of you can use this whiteboard function on on Bliss and draw like this. You can try. Okay, maybe Yechan, you could show us. Yechan, you there? Can you draw one for this one? And maybe Yale, you can try maybe this one. You can try. You can just click on that and just draw on it and show it to other people. If you are confident, all right? Anyone confident can try. I've got I'll get Yechan to do the first one. Yeah, come on, do it. Yeah, you can use your cursor to just do it, you know. I'll make an axis for you. So that and that. So Yechan's gonna do this one. Does anyone want to do this one? So what would the Pentek function look like? This is a quadratic, this is cubic, this is a... Yeah, Chris, do you want to try? You can draw here. I'll give you a clue. I'll give you a clue. So for it's very similar to this one. Yeah, I think Chris is doing a good job. That's very good. That's very good. Yeah. Okay. So Yechan, you can do this one. It's not working? No? Okay. So it's actually, I'll just do it for you. You have to click a pen. Yeah. Yeah, so it's like that. So yeah, all good. So Chris has done a good job. Yeah, so this one can have 1, 2, 3, 4, 5 roots. 1, 2, 3, 4, 5 roots, okay? Now using this knowledge, you can pretty much plot anything, any polynomial that looks like this one, okay? So let's try this one, all right? I'm gonna click on this one, copy, and go down here and paste. Okay, so this is x-axis, y-axis. So when does this polynomial become 0? When does it become 0? That's when x is equal to 1, x is equal to 2, or x is equal to 3. So the roots are 1, 2, 3. So the polynomial, whatever this polynomial is going to pass through these 3 points. And this one is cubic, isn't it? So this one is cubic. This is a cubic. So it will either look like that or like that. True? Well, we have to look at the leading coefficient though. So when we actually expand this one out, this is x here, x here, x here. So when you actually expand this one, there's no negative sign there. You see that? So when you expand this, it's going to take a long time, but probably you're going to get 3x to the power of 3, which is positive. So you're going to get this one. So all you have to do is, okay, we start from there. It passed through this, passed through that, passed through this. That's the graph of the cubic function, which is factorized like that. We'll have a look at another one, which is a bit more difficult. So polynomial is 3x. 1 minus x squared, 1 minus x minus 2 to the power of 3. We're going to try this. Okay, so this is not difficult at all. Just have a look. So let's have a look at the roots first. So the roots are, when is this one 0? When x is equal to 1. Right? So 1. When does this become 0? When x is equal to 2, right? So 2, right there. And also this whole thing can become 0 when this x here becomes 0. Is that right? So that's also another root. Now let's have a look at the overall order of this one. This is power 1, 2, and 3. So the overall order of this one is it's power of 6, isn't it? Power of 6. But the pattern just continues. If it's even number, let me just go back to this. If it's even number, have a look. This. Look at that one, and look at that one. You can see that they're facing the same direction. Okay, both of them, like both up or both down, both up or both down. For odd number, this one here and this one here, one's facing infinity, one's facing negative infinity. Is that right? So here, one's facing infinity, one's facing negative infinity. So the pattern just continues. If it's power of 6, that's even number, right? So it means it's gonna be boo, 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 like that, or like, like that, Sure? So it's both facing down or both facing up. So we just have to figure out whether when this is expanded out, you're gonna get like x to the power of 6, and then blah 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 blah. Long expression. It's gonna take a while to expand this. But I believe that it's gonna be definitely 3 because it's just x there, x there, x there, but there's a 3 at the front. So it's going to be 3x to the power of 6, but can you predict whether it's going to be plus or minus? I want you to type the answer on the chat box. I'll give you 30 seconds to do it. I'm waiting. Okay, I got one answer. Okay, 2 answers, they contradict each other. Sorry. You can write your answer in the chat. There's a chat function on Blizz. So another person said plus, another person said plus. So yeah, Philip said plus, of course. You guys can see his answer. Michelle said plus. So most of you, yep, plus again. So Yechan and Chris just shared their answers to me personally, privately. The answer is plus. Okay. Most of you are right. It's plus. The reason is this is negative here, right? This is a positive here, negative here. But then if you square, the negative is going to cancel out, is it right? The negative is going to cancel out. So the answer is just positive. There's no more negative left. So it's going to be both pointing upward, okay? So definitely it's going to be like, it's going to look like this, both pointing up, like that way and that way, okay? Now it has to pass through these, but it has to pass through this in a straight manner like that, just cut through it because it's power 1. Now if it is square, I said there are 3 different types, right? Mainly, so there's a cut through. If it's power 1, just go through it. If it's 2, then bounce off. Power of 3, then pass through in a flat manner at that intercept. So I want you guys to actually try this. Maybe I'll draw 4 axes. You guys can all do it on. So I'll draw maybe 1, 2, 3, 4, 5. 5 students here. So I'm gonna draw. Okay. You guys should all use your mouse to do it here. Okay. So maybe Yechan here, Chris here, Yael here, Michelle here, You can try on paper first, and then draw here. And fill it. Okay? The clue was, you know, this is Johnny's. 0, 1, 2, and it's that way and that way. You can do it on the screen only if you want to. You don't have to do it if you're not so confident, okay? If you're confident, then you can try. I'll give you some time, okay? Maybe 1 minute to think about. I'll give you maybe one more clue. So this is 0, this is power of, this one gives you the 0, it's power of 1. So we actually talked about this one, pass through this one. But then it has to sort of like go through that and then bounce off. I mean, go to infinity. Does anyone want to show? You can use this to draw like that, you know. If you're having trouble, just on the chat box, you can ask me a question like personally. Instead of talking to all the other people, you can just choose to talk to me only and then write a message. Then I can give you some help. Ah, Chris is leading. Oh, you shouldn't click on this. You shouldn't click on that. You should click on the, it's a separate, yeah. Yeah, you have to click on whiteboard on Blaze. Click. Yeah, click on pencil. Instead of cursor, click on pencil. Yeah, it doesn't draw? Do you see this button here? Can you see my cursor? Oh, maybe you can't see. All right. So you got to go to whiteboard on Blizz and click on, instead of a mouse cursor, you have to click on pencil and it'll let you draw. Yeah, Chris is doing fine. Anyway, let's go through this. All right, people, I'm going to finish this. Or Chris, do you want to finish? Okay. All right. So that's Chris's answer. Well done. Was not right. Okay. Yael, do you want to try? Yeah, I can hear you. Yeah, of course. Everyone can hear you. How do you draw? How do you get a pencil? Okay. So it's on it's very hard to explain. So do you know how to chat? Right? You can type, right? Yeah. On Blaze, that's right. And there is just above chat there's something called whiteboard. Do you see that? If you just click on that, you get all kinds of things. You know, there's a highlighter like this one. There's like a pen as well, like this. You're not supposed to use these here. That's just for me. Okay? Oh, it's not working. Okay, I'm not sure why. Well, you can use your cursor, right? But it doesn't let you draw, does it? But do you see like an eraser? Do you see like a highlighter on under the whiteboard? Okay, let me just have a look. All right. So yeah, I allowed everyone to be able to draw. Okay, it's a bit weird why it doesn't let you. Yeah, I can see all your cursors, but it doesn't let you draw. Okay. Anyway, all right. You can use your mouse and just click, hold click, and then like drag. That's all you have to do. But it doesn't let you do it, right? Okay. Okay, that's fine. I'll just yeah. You can do it on a separate piece of paper. That's fine. All right, let's finish this one. Okay. So this has to go through this one. And then this is 1 here, right? But this is a square. What do you have to do when it's square? You have to bounce off of it, right? So you have to go there and then bounce off of it, like that. And then for this is 2, this is 1, this is 0. You have to go through 2, but this is the power of 3. So you can go through this, but flatten there and then like this. Okay? So that's the graph of it. So does that make sense? Okay. All right. Maybe we'll try one more. Polynomial equals to minus 3 plus 3, 1 minus x to the power of 3, x minus 2, x plus 3. So we'll draw this one. So listen very carefully, okay? I'm gonna go for maybe this is 3, 1, 2, 1, 1, so it's power of 5. Okay, sure. So in this case, you can see that it has to go through 2. So let's go for that's 2, and this is gonna give you has to go through 1, and this has to be, because it's plus 3, x has to be minus 3 to make that 0. So it's a 0, 1, 2, 3, somewhere around there. Minus 3. And the overall order of this one is 3, 1, 1. So the order, this is a 5. The order is 5. So we have to figure out whether it's going to go like that or kind of like this, you know? Let's figure it out. Now, when you expand this one, is it going to be plus 3x to the power of 5 or minus? I'll give you 1 minute to think about it. You can write your answer on the chat box. I'll be right back in 1 minute. All right, many people are saying it's negative, and the answer is negative. That's right. So this is a negative to the power of 3. That's all positive, positive, but you have to just figure out whether the negative sign eventually survives or not. But in this case, it survives. So this is definitely going to be negative. So it's going to be this case here. So it's going to be pointing downward that way, and after this point, it's going to shoot upward that way, okay? So that's going to be the shape. Now you have to figure out, this is a 1, this is 2. So you can now draw. If it was cubic, then it has to go through that point like that. If it's square, then it bounces off that point like this, or if it's just if it's power 1, then it just goes through it. Yeah. Okay. So, I'll give you like 30 seconds to try this. This is power of 3 there. I mean power of 1 there. 1 there, 3 there. Yeah, try for yourself maybe on piece of paper. You don't have to do it on the screen. Chris, do you want to have another go on the screen? Okay, good try. Yael, do you want to try? Does your whiteboard work? How about you try using the highlighter? Try both. Okay, so it's a bit weird. It should work. Okay, let's go through this. So this is a x. This is power 1. So it just has to pass through that point. So it just passes through that like this. Okay. And this is power of 3 there. Then it doesn't bounce off. It still goes through it, but it has to flatten out like this, and then go through like this. Okay, do you understand? And then it has to go through 2, but it's power 1, so it just has to, pass through it like this. That's it. All right. I can show you I can actually use the Casio calculator. Just take a look at this. I'm going to go to graph, and I'm going to type 3 bracket 1 minus x to the power of 3, and then x minus 2, and then x plus 3. I'm going to ask this graphics calculator to plot. All right, let's take a look. So it seems to be, hold on, maybe I made a mistake. It's a 1 minus x to the power of 3, x minus 2, and then what did I do? So let's try again. 1 minus x to the power of 3, bracket x minus 2, x plus 3. and draw. I'm going to go to window. I'm going to go for -3 to about 2, yep, and scale minimum maybe -100 to 20, something like that. Yeah, so you can see that it's very similar. So this one goes down like that. So like this one here goes down, and it's very difficult to see what's going on there. So let's just zoom in there, okay? To see what's going on. So I'm going to go to up window, maybe go for 0 to maybe 3. I'm just going to see from 0 to about here. And y minimum is going to go for maybe -3 to about 10 and see if that gives you something. Yeah, there you go. So it's like that, isn't it? It flattens out. This is 1 and then rises and then falls. So exactly the same shape as this one. All right, so that's how you plot any polynomial. All right. Now we're going to move on to the next topic, which is, it's related to this one. It's related. Okay. Factorizing. This is a very important topic, polynomials. So for example, if you have y equals to, I'm going to just bring up an example. Just give me a minute. If you have a polynomial that goes like this, x squared plus 4x plus 3, which is a quadratic, this one is easy to factorize, isn't it? You know, quadratic is very easy. You just have to come up with two numbers that multiply to give 3 and add to give 4, and that's the answer is x plus 1 and x plus 3. And how do you plot this one? It's simple. It's a -1, -3, -1, -3, and it's a smiley face, right? So you should know that quadratic is a type of polynomial. Also, if you have something like, if you also have non-monic, we talked about, this is a revision from last time, okay? Non-monic factorization. Let me just bring up an example. If you have something like, you know, y equals to 3x squared plus 25x plus minus 18, then, you know, you've learned the cross multiplication method. 3 times 1 is 3. 18 is made up of probably 2 times by 9. You can do that. 3 times 9 is 27. 1 times 2 is 2. So we want to make 25 with those two. So if this was -2, then we get 25. So therefore, 1 times -2 is -2. So therefore, the bracket for this one is 3x minus 2 and x plus 9. Right, and then how do we plot this one? It's also very simple. You have -9 here. And you have to think about what makes this one 0. So if we make 3x minus 2 equals 0, then 3x equals to 2, x is equal to 2 on 3. So another root is here, 2 on 3. And this is also a smiley face. You can see that one there, so it's actually that way. So this is how you plot this. Of course, you can find the y-intercept and the vertex as well. And we covered all of this in the previous lecture when we talked about the 3 different forms of quadratic, right? So they're all related, you know, y equals to ax squared plus bx plus c, y is equal to a, x minus alpha, x minus beta, y equals to a, and then x minus h squared plus k. So if you missed on this lecture, it's available online, so you can just I can give you this video. All right, so that's how you factorize a quadratic polynomial, right? Here we learned about how to plot polynomial once they are factorized. True? So this one is about how then do you factorize? We know how to plot when they're factorized. How do you factorize? So this is a way to do it if it's quadratic. Now from cubic, there is no simple factorization methods. I'm going to write it down, okay? So from cubic onward, no simple or systematic way or any formula to factorize it, okay? It involves a bit of trial and error. So from cubic onward, okay? So let's try factorization of a cubic one. Just going to bring up an example. Cubic factorization. Okay. So let's say you have a polynomial given by y equals to x to the power of 3 minus 4x squared minus 7x plus 10. You have to look at the factors of this one. So you can see that the factors of 10 are 1, 2, 5, and 10, right? So what you have to do is try plugging in. So this is f of a, I'm going to call this p of x, okay? So let's try plugging in 1 in here, okay? So you get 1 to the power of 3 minus 4 times 1 squared minus 7 times 1 plus 10, which is just 1 minus 4 minus 7 plus 10, you know? So this is a 1 minus 4 minus 7 plus 10. And that's actually 0, isn't it? So what this actually tells us is that this can be actually factorized into x minus 1 times by something, okay? So when you plug in x equal 1 there, it was 0. What that means is this value is y, true? This value is x. So it goes through this point right here, which is 1, 0. So if it goes through, so if this, whatever this polynomial is, if this goes through 1, 0, that means this can be factorized into like x minus 1 and something, you know, maybe 2 more brackets like this. All right. Now we can try what's called a long division. Can you type on the chat box yes or no to this question? Have you done long division before? Yes or no? I've done long division. Yes. Someone said yes. Yep. What about 3 other people? Maybe yes, no. All right. We're still gonna go through this, okay? Because I think it could be a good revision. So what we're going to do is, now that we found that x minus 1 is a factor, we're going to divide this by this to see what this is. Does that make sense to you? So for example, if you have 10 and you found that 2 is a factor of 10, then you divide the 10 by 2 to figure out what the quotient is, right? So that's why we divide this by this. So this is cubic. So it's x to the power of 3 minus 4x squared minus 7x plus 10. And by luck, we found that x plus 1 is a factor. Now we're going to try this. So x times by x squared can give x to the power of 3. So this is x to the power of 3. So this time this is this. And this times by this is, we're going to multiply this by this. So you get plus x squared. And then you have to subtract. So the procedure is very, very similar to something like this. You know, if you have like 102 and you divide this by, let's say, 5, then you try to figure out how many 5s can fit in to 102. The answer is like 20, and then the 5 times by 20 is 100, and the remainder is 2 in this case. But so in this case, 5 is not a factor of 102. All right, someone asked me, oh, it must be x minus 1, sorry. Yeah, thank you, Michelle. Yeah, because x must be 1 to make this one 0, so factor is x minus 1 instead of x plus 1. Yep, that's good. And this has to be, of course, minus. Now, if you have 100, and of course 5 is a factor, and of course 25s can fit in there. 25s can fit in there. Then you get 100, and then the remainder is 0. Okay. Now, if we do this procedure, the remainder must be 0. Do you understand? Because this is a factor. So we're just seeing how many x's can fit into x to the power of 3. The answer is x squared. So you multiply this by this, you get that. Multiply this by this, you get that. And then you subtract. So then this and this is gone. This and this is gone, right? And then you do this minus this. Negative 4 minus negative 1 is negative 4 plus 1. So it's minus 3x squared. And of course, this is all 0, 0. Okay, so this times by this is that, and 0, 0. So this minus this is still negative 7x. You just bring this down like this. And then you have to also think about how many of this can fit into this one. The answer is negative 3x. So that this times by this is negative 3x squared. And this by this is a positive 3x. Positive 3x. And you subtract again. This and this is gone. This and this is a minus 10x. This minus this plus 10. And now how many, what should you multiply to make it equal to this one? So that's equal to minus 10. So x times by minus 10 equals to minus 10x. And this by this is a plus 10. And if you subtract, you get exactly 0. So what that means is that this original polynomial, which is x3 minus 4x squared minus 7x plus 10 is equal to, you know how 100 is made up of 5 times 20? So this one here is made up of this by this. So it's an x minus 1 and an x squared minus 3x minus 10. Now we don't need any luck to factorize this one. We know that, 5 times by negative 5 and 2 can create minus 10. So, negative 5 times by 2 is minus 10. And negative 5 plus 2 is equal to minus 3. So this whole thing can be now factorized into x minus 1. This is x minus 5, and this is x plus 2. So 5 and 2. Negative 5 and 2. Okay? So now we can plot. So this is all factorized. So the equation is now, so 1, 5, minus 2. And it's a cubic, and it's all 1, 1, 1. So it's just going to pass through all of this just once like that. Okay, so that's how you do it. Now, this is rather taking long time, so this is called long division. As the name indicates, long division takes a long time. but there is something called synthetic division. So this is going to be a lot faster. Synthetic division. All you have to do, so instead of writing your box like this, you put the line under, and all you have to do is just take the coefficients of these numbers. So this is a 1, minus 4, minus 7, and 10, right? And all you have to do is, this is x minus 1, but when you plugged in 1, then you got 0. So all you have to do is place 1 here instead of negative 1, okay? Now here's the method, so it's going to be quite interesting. Drop the 1 down, and 1 times by 1, you should get this method, you should see the pattern, okay? So bring the 1 comes down. 1 times 1 is 1. Instead of subtracting those two, add them, so minus 3. 1 times 1 minus 3 is minus 3, and then add them up, so minus 10. 1 times 1 minus 10 is minus 10, and add them up, then you get 0. So that is the remainder. And this, you know, this was x to the power of 3. This was x to the power of 2, x to the power of 1. This is x to the power of 0. Now this one is 1 or less. This is x squared, x, and just the constant, right? So the answer is, you get x squared minus 3x minus 10. So which is the quotient right here. So instead of this long division, you can do this synthetic division. This is a lot faster. All right. So let's try another problem. So first you'll have to plug in some numbers to let me just bring up another example. Okay, there it is. So a polynomial is given by, so this is a cubic. Okay. So we're going to factorize this one and plot. We're going to factorize and plot. So this one is, you can see that actually all of this is divisible by 4. So you can actually, first of all, before you even begin, you can factor out 4 and you get x3 plus 3x squared. 4 times by what is 64, 16. And what's 192 divided by 4? 192 divided by 4, it's 48. So this one is 48 there. Now you can try plugging in some numbers and see if you're lucky enough to make this one 0. Okay, and you can write your answer. You can share your answer on the chat box. Okay, I'll give you 1 minute for that. Just plug in maybe 1 or 2 or -1, whatever you want. But it must be a factor of 48. Well, there are many factors of 48. 1, 2, and 3, 4, and even yeah, 6, what else is there? Yeah, many. 24 as well. Yeah, so for cubic, the only way to find x is by guess and check. Yeah. Yeah, for some question like that, you can share that question to everybody. So instead of just me, you can type that to everyone. Yeah. So teachers, of course, will give you a polynomial that has easy roots, like 1, 2, or 3, things like that. So does 1 work? If I plug in 1 here, so I get 1 plus 3 minus 16 minus 48, but that doesn't work. It's negative 60. Because these are huge negative numbers, so probably let's try, maybe this and this can cancel out if this is like 3. So I'm going to go for negative 3, okay? So if I go for negative 3 to the power of 3, that one there, plus 3 times by, negative 3 square, which is positive 9, minus 16 times by negative 3, minus 48, or 0. That means, so p of minus 3 equals 0. That means x minus x plus 3 is a factor. Now divide this by x plus 3 by long division, or we can try 4, 12, minus 64, 192, and then minus 3 here. You can try both. I'll be right back. All right, so this is, I'm just going to go through it quickly. You guys can copy this down. So multiply this by x squared to match this x to the power of 3. Then this by this is 3x squared. So subtract, and even this is gone as well. So 0, 0. So this minus this, this minus this, this minus this, and this minus this. And you get, if you want to match that, you get minus 16 there. Then you get minus 16x. This by this is a minus 48. So you get 0. So what you get is, so this whole thing is now factorized into x plus 3, that one there, and x squared minus 16. But now this one is easy to figure out. You know that a squared minus b squared is a plus b, a minus b, right? So this is one of the basic rules of algebra from like year 10. So this is x plus 3, and then this is x plus 4, and then x minus 4, right? So I can factorize like that, So yeah, this is long division. You can try this one. Drop 4 down. Oh, hold on. We don't have to do 4. This is 1, 3, negative 6. I use this one. But yeah, I can change that. So this is supposed to be 1. You're using this one. 1, 3, minus 16, minus 48. So drop 1 down. Sometimes you'll see that this is not always 1. You might have 2, or in this case like 4. It still works. Negative 3 times 1 is minus 3, which is 0. And then this times 1, 0 is 0. Add them up, then you get negative 16. And this by this is negative 48, positive 48. And you add them up, you get 0. So that's remainder. Of course, remainder is 0. So this was x to the power of 3. So this must be x to the power of 2. So the quotient is x squared minus 16. Okay, so that's how you do it. So therefore, this is the original thing, original polynomial, and this became that, and that part became 4, and then bracket, 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 you know? So this thing becomes these three. X plus 3, x plus 4, x minus 4. And this one is so easy to plot, you know? Because everything is, this is cubic, it's going to be in this shape. Because it's all positive, A is positive. Plus 4 from here. Minus 4 from here. And minus 3. And it's just going to pass through each. No bouncing off, no flattening out. It's just passing through, you know. That's it. That's the graph of it. Okay. What was the next topic? So we talked about long division, polynomial, synthetic division, factorizing cubic and quartic, factor theorem, and remainder theorem is the next topic. Okay. We already talked about factor theorem, remainder theorem. So this is also quite important. So factor theorem. If P of alpha equals 0, then x minus alpha is a factor, write this down, of the polynomial. So we already went through that, you know. When we did P of 1 and this was 0, then, you know, we said x minus 1 is a factor of the polynomial, and that's what we use. You know, we divided this by this and did the long division and synthetic division. I'm just writing down what the theorem says, you know. So this is the formal theorem. So we've been using this theorem. Okay. Now I'm going to go through remainder theorem. So what's a remainder theorem? If P of alpha equals to R, then R is the remainder when Px is divided by x minus alpha. So copy this down. And definitely, of course, this one is not a factor. Because factor is something that divides the polynomial without any remainder. If there is a remainder, then it's not a factor. Okay? So now we're going to go back to this example. Where was the example? So we're going to bring perhaps this guy here. I'm going to bring this guy to here. Okay, we're going to divide this by some random expression. So we're going to divide this by maybe x plus 4. So I'm going to do the long division and figure out what the remainder is, okay? So times by x squared x3. This times by this, subtract 0, negative 8x squared. This one comes down. Now multiply by negative 8x to match this one. So you're trying to find out what the quotient is so that this can match that one, okay? So you multiply this by this, you get this one. This multiply this by this, then you get negative 32x. And this is 0. This minus this is 25x, positive. And then this all comes down. And then I match this one by multiplying by 25. Then I get 25x. This by this is 100. So I get negative 90, which is the remainder. I want you to check if you get the same answer using the synthetic division. So probably this is first time for everyone. 1 minus 4 minus 7 plus 10. And what number do you have to plug in here? It's minus 4. Because I'm dividing by x plus 4. The one that makes this one 0 is minus 4. So try this and see if you can get negative 90 here. Just tell me on the chat box if you got negative 90. Just type, yes, I did. Okay. One person said, yes, I did. One person said no. Okay. Okay. One more person said yes. Let's do it together. So 1 comes down. This by this is minus 4. And you have to add them up. Here you subtract. Here you add, you know. It's minus 8. Which is exactly this one. 1 minus 8, you know. This by this is 32. And add them up, you get 25. And this by this is minus 100. Add them up, you get minus 90, right? So that's the remainder. That's the quotient. Okay, so we call this guy the divisor, right? The one that divides. We call this one the quotient. Right. So we found the remainder by either doing this way or this way. I want you to actually plug in minus 4 in here and see what you get. Just plug in minus 4 in here, here, here. Minus 4 to the power of 3. Minus 4 and then minus 4 squared. Minus 7 and then minus 4. And then plus 10. Simply plugging in minus 4. Let's have a look. Got the calculator here. Okay. Minus 4 to the power of 3. Minus 4 times by minus 4 squared. Minus 7 times by minus 4 plus 10 minus 90. So I can simply get the remainder by plugging in minus 4. So if you want to know this, so what is the remainder when I divide this When I divide this by this, you don't have to do the long division. You don't have to do even the synthetic division. You can just get the remainder by just plugging into the polynomial. So what's the point of doing the long division or the synthetic division? You know, synthetic division, long division. The point of doing the division is to find the quotient, you know, as well as the remainder, Understand? So, but if you just want the remainder, you can plug in, and that's what this remainder theorem is saying. If you plug in something and you get the r is the remainder. Okay, when this is divided by, if you plug in alpha, then when it's divided by x minus alpha. Of course, this is not a factor. Maybe you might be wondering, how does this work? How? Right? Let me just go through that. So if you have like 17, if you have 17 divided by 2, then the quotient is 8, and you get the remainder as 1. So that means you can write 17 as the divisor times by the quotient plus the remainder. Is that right? So if you have a polynomial divided by some x minus alpha, and then you have some quotient here, so this by this, and then you get some remainder, I'm going to call that r, then we can see that the original polynomial can be written as x minus alpha times by the quotient, right, plus the remainder, right? If you have the polynomial and you have x minus alpha, and if x minus alpha is a factor, and then you have some quotient, and then there will be no remainder. Is that right? In that case, the polynomial can be written as x minus alpha, and then the quotient, and then nothing. No, it is plus 0, you know? Nothing there. So how does the factor theorem work? This one shows how the factor theorem works. This one shows how the remainder theorem works. So let's have a look. If I plug in alpha here, then this will be alpha minus alpha, quotient of alpha, plus 0. Of course, what's alpha minus alpha? It's 0. This whole thing is 0. So you get 0. What was the factor theorem saying? If you have p of alpha and it's 0, then this must be a factor, of course. Because as you can see, if it's a factor, then it can be factorized in this way, and as soon as you plug in, you know, if it's a factor, then it can be factorized this way without any number there, and as soon as you plug in alpha, you get 0. See? So that's what the factor theorem is saying. If you plug in alpha, you get 0, then x minus alpha is a factor. Now, how does the remainder theorem work? Let's plug in alpha here. Then, so if this polynomial is divided by this, then you get quotient and remainder. So it can be written like that. And how can you get the remainder so easily by plugging the alpha? The reason is here. Alpha minus alpha. And this is gone. Okay? That makes sense? So if you simply plug in alpha, you just get the remainder. So that's how it works. So that's what the factor theorem and remainder theorem are. So we covered that as well. We got like half an hour left. Maybe we can do some questions now. Yeah, we can do some questions. Anybody any question? Can I ask you how much you guys are understanding, maybe from 1 to 5? Okay, 5 means understand everything. 1 means totally lost. If you don't want to share, you can just send me a personal message. All right, Michelle 3.5, Chris 2.3, Yachan 3. How about Yale? 3. All right. So everyone's around the same level. What's the most difficult part to understand for you guys? You guys can type it up there. Any bit that you want me to clarify. We're going to do some questions. If you don't have any questions. Next week's lesson will be functions and relations. So we'll do more, we're going to do more, what is it? Yeah, more functions and relations. So functions and relations are like the most important topic. Okay. All right. All right. So example. Show that x equals to minus 2 is a root to px, x to the power of 3, 6x squared minus 13x minus 42 equals to 0. Hence, find the other roots. So root means x-intercept, right? You know how I said you have to do like trial and error to figure out the factor? In this case, they've given you the answer. They've given you right here what the factor is. Okay? You have to use the factor theorem. So what does the factor theorem say? If p alpha equals 0, then x minus alpha is factor, right? So in this case, they're saying that this is a root. Show that this is a root, which means if you have a p of minus 2, see what you get, you know? That's going to be negative to negative 2, which is negative 8. 6 times by this negative 2 square, so negative cancels out. This is just 4. This is a negative 13 times by negative 2, which is positive 26. And there's a minus 42. So this one is negative 8 plus 24 plus 26 minus 42. This is 0. So see, this is factor theorem. P alpha 0, then x minus alpha is factor. P minus 2 is 0, then what is a factor? You can type it up here. Type the answer. Therefore, this is a factor. Can you type your answer on the chat? Just use this. I'll wait for you. Take your time. x something. Nobody? Yetchan said x minus 2. Yal said x minus 2. Michelle, where do you get the negative 16 from? The answer is x plus 2. That's okay, Michelle. All right, so look, alpha is minus 2, right? So if you have p of alpha equals 0, so if you plug something in, you get 0, then x minus that number is a factor, okay? So I plugged in minus 2 right in here. Then this must be a factor because if you follow the rule, all right, so I'm just going to exactly copy this, okay? So p of minus 2 equals 0. Then x minus negative 2. So this negative is already there, okay? And what's alpha? Alpha itself is minus 2, right? So it's a minus of negative 2. So this is equal to x plus 2. So x plus 2 is a factor. Now, so we found one factor, so we can actually reduce this cubic. We can reduce this cubic now down to quadratic. Is that right? So you can do the long division or synthetic division. It's up to you. Let's do synthetic division. I think you guys are all good at this now. Okay, 1, 6, minus 13, minus 42. And in this case, the minus 2 goes here. For long division, x3 plus 6x squared minus 13x minus 42. And you divide that by, in this case, x plus 2. Okay, so if you do this, then you can find the quotient. Of course, the remainder will be 0. Try that. Figure out the quotient. Okay. It's your turn to try. There is really no point. You know, I've explained already everything, but unless you guys try this for yourself, it's really not gonna, you know, stick around. Yechan, do you want to write on it so your whiteboard doesn't work still? No, I was talking to Yechan. Hey Yael, do you know how to do this one? Synthetic division here? Did you get an answer? Okay. You can do the long division if you want. It's up to you. What do you get for the quotient? Haven't tried yet? Okay. Yechan, do you understand synthetic division? Okay, so Michelle got an answer. She's saying that this has to be x squared plus 4x plus 20 minus 21. Let's see if we get the same thing with the synthetic division here. So if we bring down the 1, so if you don't know synthetic division, pay attention to what I do here, okay? So you just write the coefficients, 1, 6, minus 13, minus 42, like that. And then this is x plus 2, so it's minus 2 here. So 1 comes down, negative 2 times 1 is minus 2, and then this add together to get 4, and then negative 2 times by 4 is 8, and then you add them up, then you get minus 5. Not negative 21. So let's try on the long division and see if we get the same thing. So x squared then you get x3, 2 times by this is a 2x squared, subtract, then you get 4x squared minus 13x minus 42, then it's plus 4x, then you get 4x squared, this by this is plus 8x, subtract, minus, it's 21. Subtract, right? What did I do wrong? Oh, it's a minus 8 here. Sorry. Yeah, it was, so Michelle's right. Yeah, definitely it's negative 21. Well done, Michelle. So yeah, you subtract this, then you get negative 21. Negative 21x minus 42, and if you multiply this by negative 21, then you get negative 21x, and 2 by this one is minus 42, subtract, then you get 0. Okay? So definitely, if you learn synthetic division, you can do it a lot faster. You can see that, right? So let's go back to the actual the wording of the question. It says show that x minus 2 is a root to this one. Hence find the other roots. So we plugged in minus 2 and found that this is 0. And therefore x plus 2 is a factor. Right? So this is a root. So I'm just going to write it down. Minus 2 is a root to px equals to 0, because when you plug in minus 2, it is really equal to 0. Now we say x plus 2 is a factor to px, not px equals 0, okay? So this is a root to this, therefore this is a factor according to what theorem? The factor theorem. Through synthetic division or long division, qx, which is the quotient, is equal to x squared plus 4x minus 21, which is that one there. And we know that polynomial is made up of x plus 2, so that one there, that one times by this one, and that one, right? And, for quadratic, we can simply, factorize that easily. Or use, if it's not factorizable, you can use quadratic formula. So 21, I think, what times what? 7 times by 3? That's right. So x times by x plus 7, x minus 3, and x plus 2. So this is factorizing to those two. Yep, that's the end of the question. So the other two roots are x is equal to minus 2 is a root. The question says what? Find the other roots. So we're looking for something like this guy. So that's a factor to this one. That's a factor to this one. That's a factor to this one. But x equal minus 2, minus 7, and 3 are roots to polynomial. That's not right. You got to write 2 polynomial equals 0. Okay? So to this one. It doesn't make any sense mathematically to say that these are roots to just polynomial. Got to include 0 always. As you do more maths, you get to understand more and more, and you will understand why there must be 0. Okay? I'm not going to explain that today. Okay, can you type 1 to 5 on the chat box, your understanding level for this question? 1, totally lost. 5, a 3, all right. 5, I totally get it, too easy. So someone asked me, is factor always given? If not, how do we figure it out? Okay, so in this case, the factor was kind of given, right? So they said x minus 2 is a root, so we could easily find that the factor is x plus 2. So this is not always given. Sometimes you have to figure it out yourself by trial and error. You have to plug in like 1 and see if it gives you 0. You have to plug in 2 to see if it gives you 0. Okay? Things like that. Yeah, so for this question, could you type in your understanding level, 1 to 5? I only got 2 responses. Okay, some people are saying 2, 4, 3.5-ish. Okay. All right. What does 2 mean? Someone said 2. Philip, you actually made your response public. So what do you mean by how are you coping with this question, Philip? You get the division part. Which part do you don't get? Okay. But do you think your understanding will improve if we go through like more examples, or repeat this, do a few similar problems? Okay. Sure. Okay, we'll do another problem. In this case, you know how we went from equation to graph? We're gonna go from graph to equation. So there's a graph going like this, and you're gonna have to figure out the equation of this one. So this is a root, which is 4. This is another root, which is half. There's another root, which is minus 3. First, answer this question. Quadratic or cubic? So quadratic or cubic, quadratic or pentek? Second, what are the roots? Therefore, what are the factors? So answer this question first. And also, is alpha positive? A positive or A negative? So we learned about this one at the start of this lesson. So definitely the roots are, I already told you this one, so it's minus 3, 1/2, and 4. So therefore the factors are x plus 3. And for this one here, you have an option of doing x minus half. For this one, of course, is x minus 4. But for this one, you can do this one or 2x minus 1. Because, if x is equal to 1/2, then this is 0, so that's fine. Also, if x is here is equal to 1/2, then this will be 1 minus 1, so that's also fine. But for now, we're going to stick with this one, okay? So this might be a little bit confusing for some of you. Then you have to come up with y equals to, so this one, this one, this one's made up of those 3. And there must be always this number at the front. This could be 1, we don't know, so you have to figure this one out. That's the leading coefficient, so this is a x plus 3, x minus half, and x minus 4. But you have to come up with number here number here, and number here, based on the look of this graph, okay? Yeah, I'll give you 1 minute. Oh, by the way, the clue for figuring out A is that this y-intercept here is minus 96. So without this information, you cannot actually figure out what A is, okay? So figure these out, fill in the numbers for these boxes first, and then we'll figure out A together, okay? Be right back. Okay, Chris, you asked me a question. So for synthetic division, why is the first number 1? Like for this one here, you see this is we're only taking the coefficient of these numbers. So this is 1. It's actually not visible there, but it's actually 1 there. 1, 6 minus 13 minus 42. So that's why it's 1, 6 minus 13 minus 42. So if this was like 2 here, then you would write 2 here. Okay? Yeah, sometimes 2 is there instead of 1. Anyway, so what's the number for this box? The answer is, this is 1, 1, and 2. Someone said why? So this is 1, 1, and 2. Because it just passes through that, crosses, you know. So, you know, we talked about this, x minus alpha to the power of 1, it just goes through it. X minus alpha squared, then it bounces off. X minus alpha to the power of 3, then it's a cubic like this. So as you can see, it bounces off, you know. So this is square, so like this. So the equation is now y equals to a x plus 3, x minus half square, okay? But I want you to notice something. So depending on this value a, so I want you to consider a few things. You can have a 1, x plus 3, x minus half, x minus 4 square. I want you to also consider like 2. So both equations here, whether it's 1 or 2, they appear to be, they look very similar, you know. They all look similar. So it goes through minus 3, it goes through minus 3, it goes through, you know, half, and goes through 4. That's a cross, cross, and bounce. So it's a cross and cross and bounce, right? So whether it's this equation or this equation, they both have to cross this one, and bounce this one because of the because of this and this and this. But when you have like 2, this is double. then it's going to be a little bit different. If it's one, how to compare these two? This one is a bit more stretched. So let's say I just drew this one. If I draw this one, it's a bit more stretched. It's like that, that, and that, and like that, okay? So on the positive side, it's a bit difficult to explain, but you just have a look. So this is for that guy there, and the black one is like this one, that, and like that, okay? So depending on this value, 1 or 2, you see, this value here, like this value here, can change, But in this particular case, that value is negative 96. Is that right? Anyway, so the y-intercept, you should know that the y-intercept is when x is equal to 0. So whatever the a is, when x is 0, y must be negative 96. So this point here is negative 96. So I'm going to use this equation. So we don't know a yet, but we're going to solve for a. So negative 96 equals to a, and then x is 0, 0, 0. So this is a 3 minus 0.5 and negative 4 square, but square is positive, so that's 16. 4 square, 16. And this is negative 96 equals to a. Well, what's a half of 16? This times by this is 8. Negative 8. Negative 8 times by 3 is negative 24. So if we divide by this, then you get a equals to 4. And indeed it was a positive value, because it's like both going to positive infinity, So a must be 4. That's why. So it must be more like this, Hold on, my keyboard is not working well. So it should be more like that, and like this, and that there is negative 96. And that is y equals to 4, this, and this square. Goes through that. They all do the same thing. So like this, okay? Yeah, and that's 96. If it's 1, then this value here would not be negative 96. It'll be just negative 24. This value would be negative 24. If it was 2, then it'll be negative, I think, 48. Just twice that, okay? And there's 1, 2, and this is 4 right there. All right, let's try one more problem. We got like 2 minutes, but we started a little bit late, so we'll try a few more. Okay. I ran out of space, actually. Maybe I can use this space here. Oh, that space here. Okay, the question is, the polynomial, this is question, write this down. So this is a polynomial. Well, we don't know a, that's the coefficient of x squared, and we don't know b, that's the constant term. This is divisible by x minus 2. So this, whatever this is divisible by this. That means remainder is 0. No remainder. But it has remainder of 6 when it's divided by x plus 1. So when you divide this, by this, remainder is 6. When you divide this by this, it's divisible. Okay? So in this case, you might be thinking, oh, maybe I should divide this by this, but that's too difficult because there's a and b involved and they're not numbers, you know. You don't need to do synthetic division. You can do what's called the factor theorem. So we learned that, and remainder theorem. Okay. Now, I'm going to use the factor theorem for this one. So factor theorem again says, if P alpha equals 0, then x minus 2 is a factor. X minus alpha is a factor. So when this is say this polynomial is divisible by that, that means that's a factor. It goes out the other way as well. If this is a factor, then this is 0. Okay, so if x minus 2 is a factor, then what must be 0? P of 2 must be 0. Is that right? So I'm going to plug in 2 here, and that has to equal to 0. Is that right? So if I plug in 2 here, that's 8. I'm going to put 2 here, that's 4a. 8 times 4 is 4a. And this is a 2 here, so it's minus 6 plus b. So whatever that is, because this is a factor, when I plug in 2, it has to equal to 0. Okay? I want you to type 1 to 5 for this part here. I want to get some responses. So 1 to 5. Come on. Okay. 3. 2. Maybe it's too hard. 3. Okay. Yeah, everyone's saying like 2 or 3. Now, so we just have to go back to the factor theorem, remainder theorem. Okay, so remainder theorem says, just going to try this one now. If P of alpha equals to R, then R is the remainder. Is that right? When divided by x minus alpha. So when we divide by this, remainder is 6. So that means P of minus 1 must equal to 6, because that's a remainder. Therefore, I'm going to plug in minus 1 here, minus 1 here, minus 1 here. Let's just finish it. So maybe you guys can rewatch the video and maybe try the homework. I'm going to give you really easy homework. Okay. So it's a negative 1 square is 1, so it's an a. Negative 3 times 1, negative 1 is 3 plus b. And whatever this is, when you plug in negative 1, that means it's when it's divided by x plus 1, then the answer must be 6. So therefore, have a look. So this is 8 minus 6 is a 2. 2 plus 4a plus b equal 0. This one here is minus 1 plus a plus 3 plus b equals 6. So therefore, a plus b equals 2. I'm going to move and this one to the other side. Is equal to 4. Okay. And this one here is 4a plus b equals minus 2. So maybe you guys done simultaneous equation before. Now, I'm going to go back to blue again. So it's a 4a plus b equals minus 2. And a plus b equals 4. I'm going to subtract. So that's a 3a. B and b gone. So this minus this is minus 6. So a equals to minus 2. And b, if a equals minus 2, let's sub that in here. So if a is equal to minus 2, b must be positive 6 to give 4. You can use one of those equations. So b is equal to 6, which tells us that this is x cubed and then minus 2x squared minus 3x plus 6 there. So this is a polynomial. And you can try this homework. Divide this by this and see for yourself that the remainder is 0. Divide this by this, so this is your homework, and you have to write your answer on, send me the answer, okay? So do the division for this one by this and verify that it's 0, and divide this by this and verify that the remainder is 6. Okay, so we'll call it a day. This recording will be available on YouTube. I'm putting it up on YouTube. So people who didn't attend today's lesson, they have to pay for it, of course, for this video. But for those people who, of course, attended the course, it'll be all available on YouTube. Okay, and I'll send you a private link for that. Okay, and I'll send you homework straight away when I get home tonight. Okay, have fun, and let me know if you have any questions by email or chat, Facebook Messenger. All right. By the way, if you are not on the Facebook chat year 11, so we have a year 11 BSSS chat room, right? So if you're not in there, find me on Facebook. So that's my name. It's SEONG JOON. So I can add you on this BSSS chat room. Okay. Yeah. All right. That's it. See you guys next Tuesday. There will be a few more maths classes, like IB maths class, for example, running this Friday. But if that's relevant to you, I'll let you know. I'll let you know about all the topics that we cover for that day. So if you want to join, you can just let me know. All right. Any question? Okay. Have a good night. Bye. You can log off. I'll just log off. Bye.